Okay, in the last lesson we were discussing about the relationship between zeros and the coefficients of a second degree polynomial. We discussed the relation that the sum of the zeros is equal to minus b by a, and the product of the zero is equal to c by a. Today we will discuss some other idea to find the zeros of a second degree polynomial. Is there any other method to find the zeros of a second degree polynomial? Okay, so here how we did it yesterday and in the day before yesterday. So we used the method explained in textbook. In textbook how they do. For x square minus 2x minus 8, the first question is right here. For the first second degree equation, x square minus 2x minus 8. This is polynomial actually. Now we want to find the zeros of this polynomial to verify that the relations are true for this one. Okay, so the method we used yesterday is we split the middle term. Middle term is minus 2x. And do you remember how we split it for this one? How can we find
for 8x square as
production?
4
X square
4 and minus 2.
Yes, minus 4 and plus 2. Minus 4x plus 2x minus 8. And next step, we can take something common outside the bracket, right? So what can we take outside the bracket from first two terms?
X.
So x into inside the bracket, what will come inside the bracket? X
minus 4.
X minus 4 and plus from 2x minus 8, what we can take outside the bracket? 2. Then what will be inside the bracket?
X minus 4.
Minus 4. So now what is next step?
Taking x minus 4.
Yes, taking x minus 4 common outside the bracket. So what will be inside the bracket?
X plus 2.
Plus 2. So this p of x to be 0, p of x is equal to 0 in that x minus 4 is equal to 0 or x plus 2 is equal to 0. So what are the values of x?
4 and
minus 2.
4 or x is equal to minus 2. So these are the zeros of this second degree polynomial. Okay. So the different methods. So actually this comes in the quadratic equations, second degree equation. So for any second degree polynomial, you can take the corresponding second degree equation. Okay. So for the same second degree polynomial, x square minus 2x minus 8. So the corresponding second degree equation, you choose this as 0 because we want the value of x when p of x is equal to 0. So you take x square minus 2x minus 8 is equal to 0. So find the solution of this equation. That will be the zeros of this given polynomial. Okay. So we want the values of x for which the p of x is equal to 0. So you take the equation x square minus 2x minus 8 is equal to 0. Find the solutions of this equation. So the one method is like this, by splitting the middle term. And another method I shall explain. Here the method is they use the identities x plus y all square is equal to x square plus what is next term? Plus what?
Y square.
Y square. Okay. And suppose there is only one variable, and suppose y is a fixed number, a constant. So it will look like this. Suppose y is equal to 3 or 4. So x plus 4 square, how will come?
Square plus
X square plus
8x plus
yes, 8x, right? 8x plus
16.
Yes, that is 4 square, right? 4 square is 16. Okay. And if suppose the sign is minus, x minus 4, how will be this? You know the difference, right? How will be this?
X square minus 8x
X square
plus
minus
16.
8x plus 8x plus 16. Okay. So in this case, you compare the coefficients. So look here. Here the coefficients of we will arrange this given polynomial, given equation as this form. That's 1x square. 1x square. The coefficient of x will change into 1. Here it is already 1. And we will arrange the coefficients of here we look, there is no y in this last two lines. So we will arrange the coefficients of x and the constant term in this order, like this. Here there is a relation. The coefficient of x is 8 and the constant term is 16. The relation is square of half of coefficient of x should be the constant term. Square of half the coefficient of x term should be the constant term. One more example which I will write here. Suppose it comes like this: x square plus 6x plus 9. X square plus 6x plus 9. What will be here?
X plus 3 whole square.
Yes, x plus 3 whole square. A similar way, we will arrange this given polynomial as this, as the right side of this equation. And now then we can take the reverse step. Look here, the x square term is okay, the coefficient is 1. Okay, and then minus 2. Minus 2 is the coefficient of x. Minus 2 is the coefficient of x. So we can write minus 2x, no problem. Then we want to get the constant term as the square of half of coefficient of x. What is square of half the coefficient of x?
1.
Yes, 1. Very good. The half the coefficient is minus 2's half is minus 1. If you take the square of minus 1, that will be again 1. The minus 1 square is 1, right? So you want to get the third term as 1. Then you can write the reverse. Okay. So to write 1 here, we can split minus 8. We can split minus 8 as plus 1 and minus 9, right? So 1 minus 9 is minus 8, right? 1 minus 9 is minus 8. So such a way we split minus 8. Okay. So in next step we can move minus 9 to right side. So this will become x square minus 2x plus 1 is equal to plus 9. Okay. And now you compare with this identity. What all square is x square minus 2x plus 1? Now can we write?
X minus 1.
Yes, x minus 1 all square is equal to 9. Therefore, x minus 1 is equal to, take the square root to right side. So it will become root, right? So root 9. So x minus 1 is equal to, for root 9 there are two possible answers. One is plus 3 and one is minus 3. So x minus 1 can be plus 3 or minus 3. So you can write like this: plus or minus 3. Plus or minus we usually write like this: plus and minus together like this. Okay. So this can be x minus 1 is equal to 3 or x minus 1 is equal to minus 3. X minus 1 is equal to plus 3 or x minus 1 is equal to minus 3. The two chances are there. So x is equal to 3 plus 1 or x is equal to minus 3 plus 1. So x is equal to 4 or x is equal to minus 2. So we got the same zeros, right, as the first method. Okay, so you don't have to write this much steps. If you practice like this, you can avoid some steps. Okay, I think the same effort we have to take in both methods. And there is one more method, and I think you have studied in 4th chapter to find the solutions of a second degree polynomial. Suppose ax square plus bx plus c is the general form, is equal to 0. It's the general form of a second degree equation. Then to find the value of x, there is a direct method using a formula: x is equal to minus b plus or minus root of b square minus 4ac by 2a. Have you seen this before? Yes or no?
No.
No. Okay. Anyway, in this 4th chapter, quadratic equation, you will study this formula. So this is very simple. This is straight. So you look the given second degree equation and you find out a and b and c, and just substitute the values of a and b and c in this formula. You will get the values of x. Okay? There can be maximum two values for x. Sometimes it may be one, and sometimes it may be no values. Okay, so these are three methods to find the solutions of a second degree equation. So these methods also we can apply to find the zeros of a second degree polynomial. Okay.